Stable Cascade is a model which uses Würstchen architecture for efficient text to image conversion. The main feature of this model is that it is designed to be run on consumer GPUs. This is a project still in evolution, so installation is still very buggy. I have tried to install it on my local system on Ubuntu plus also on Colab in various environments, but it failed miserably with various errors. But because I still believe that this will be one of the good model in the coming days, because I'm sure that the researchers are already ironing out all the issues as is evident from the issues on this GitHub repo. I'm sure that this will evolve in a good way. Anyway, so in this video I'm just going to give you an overview of this model as how it works, because that is in itself is quite fascinating and interesting read. Now, the thing about this model is that this model is built upon the Würstchen architecture, as I mentioned, and its main difference to the other model like Stable Diffusion is that it is working at a much smaller latent space. Now, latent space refers to a conceptual space where the model captures the underlying structure or essence of the data without directly observing it. It represents hidden variables or features that explain the relationship between data points. Think of it like a hidden array where the model organizes and encodes the essential characteristics of the data in a compact and meaningful way, enabling better understanding and manipulation of the data without explicitly observing all the details. So, this is quite important because the smaller the latent space, the faster you can run inference and the cheaper the training becomes. And how small is the latent space? Let me give you an example. Just if you compare it to Stable Diffusion uses a compression factor of 8, resulting in a 1024 by 24 images being encoded to 128 into 128, whereas Stable Cascade achieves a compression factor of 42, meaning that it is possible to encode a 1024 by 1024 image to 24 by 24 while maintaining crisp reconstructions. The text conditional model is then trained in the highly compressed latent space. So this kind of model is really well suited for usages where efficiency is important. Also, there are various well-known extensions like fine-tuning, LoRa, ControlNet, IP adapter, LCM. They all are possible with this method as well, which is quite good. And if you go through their GitHub repo, you will see that LoRa is already being used in addition to ControlNet. Stable Cascade achieves impressive results both visually and evaluation wise according to the evaluation. Stable Cascade has already shown that it performs best in both prompt alignment and aesthetic quality in almost all comparisons. Now let me show you a bit of an architecture of this Stable Cascade. If you look at this picture, Stable Cascade consists of three models: Stage A, Stage B, and Stage C. All of these three stages represent a cascade for generating images, hence the name Stable Cascade. Stage A and B are used to compress images, similar to what the job of VAE in the Stable Diffusion. With this setup, a much higher compression of images can be achieved. Further, Stage C is responsible for generating the small 24 by 24 latents given a text prompts. So, in this picture, you can see that the stage A is a VAE and both stage B and C are diffusion models. Also, for this release of this Stable Cascade model, they have already provisioned 2 checkpoints for stage C, 2 for stage B, and 1 for stage A. Stage C comes with a 1 billion and 3.6 billion parameter versions, but the researchers highly recommend that to use the 3.6 billion version as most work was put into its fine tuning. Okay, and there are a lot of other details which you can check from their GitHub repo, and I'll drop the link in video's description. Let me know what do you think about this model. Pretty cool. I wish that they would make the installation and much easier and it will be less buggy. So let's wait and see, and I'll create another video when it matures a bit more. Let me know your thoughts in the comments. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network as that helps a lot. Thanks for watching.